Have you ever stopped to think about the journey your electricity takes? I mean, really think about it. It might travel hundreds, even thousands of miles, across mountains, through storms, all in the blink of an eye, just to power your screen right now. We're going to pull back the curtain on that incredible journey, on the invisible highway that powers our entire world. It feels so simple, right? You flip a switch and boom, the light's on. Instant. But behind that one simple action is one of the most complex and honestly brilliant stories of modern engineering. So how on earth does that power get from a plant miles away to your home with like zero delay? Okay, let's just dive right in. We are talking about the power grid. And I promise you, once you understand the sheer scale and, frankly, the intelligence of this system, you will never think of electricity as simple ever again. It's truly mind-blowing. So our story has to start at the very beginning, the source. Where is all this incredible power actually born? Well, it all starts at a power plant. And, it doesn't really matter if we're burning coal or harnessing a massive river with a dam or capturing the wind. All of these very different sources, they all share the exact same goal: spin a generator. That spin, that's the magic moment. That's what creates the electrical energy that's about to start this epic trip. But here's the thing. The second that electricity is created, it faces a massive problem, a mission that, on the surface, seems completely impossible. Yep, the bad guy in our story is just distance. See, electricity hates to travel. It's kind of like trying to run a marathon in a heavy winter coat. It's just incredibly inefficient. And here's why. As electricity flows through a wire, there's friction, and some of that precious energy just bleeds off as wasted heat. So, the longer the wire, the more energy you lose. Early engineers had this massive puzzle. How do you send power hundreds of miles without most of it just, poof, vanishing into thin air? Well, to solve this, they came up with an absolutely genius trick, a way to help electricity travel super long distances without getting all tired out. Let me introduce you to the unsung hero of the entire grid, the transformer. Now, this thing doesn't make any new power, not a single watt. Instead, it does something way more clever. It changes the character of the electricity, basically making it smarter for the long road ahead. Okay, so this is where the genius part comes in. Think of voltage as electrical pressure. But using a transformer to crank the voltage way, way up, you can push the same amount of power with a much lower current, or flow. And here's the key. A lower current means way less friction, and less friction means dramatically less energy is lost as heat. It is the ultimate travel hack for electricity. So, with this new trick up its sleeve, our electricity is finally prepped for its long-haul journey. It is ready to hit the superhighway of the grid. And when I say high voltage, I mean insanely high. We're talking about power lines stretching across the country, carrying electricity at over 400,000 volts. I mean, your outlet at home is around 230. This is just a staggering amount of electrical pressure. So the next time you're on a road trip and you see those giant transmission towers marching across the landscape, you'll know exactly what you're looking at. That isn't just some wire up there. It is a high-speed, high-pressure pipeline carrying raw, untamed power. But obviously, that raw power can't come directly into our homes. So now we're entering the final and maybe the most crucial phase of the journey: bringing that electricity safely down to Earth. Okay, let's put it all together. Here is the whole journey, step by step. Power is generated, a transformer steps up the voltage for the highway, it travels along those big transmission lines, and then it hits a substation. There, another set of transformers starts stepping down the voltage from hundreds of thousands to thousands until finally, a local transformer near your house brings it down to a safe, usable 230 volts. This final stage, it's all about safety. Power often travels underground in our neighborhoods through those green boxes you sometimes see on street corners. Those are the local transformers, and then into your home's circuit breaker, which acts as the final gatekeeper. Seriously, every single one of these steps, from that giant power plant to the little box in your basement, is working in perfect harmony. And the end result? It's making sure that when you plug in your phone, you get this gentle, controlled charge, instead of, 400,000 volts of raw power, which would be bad. Now, you might be asking yourself, what makes all this stepping up and stepping down even possible? Well, the answer is alternating current, or AC. This is the type of electricity that won the famous War of the Currents against direct current, or DC. And it won for one simple reason. Its voltage can be changed super easily with a transformer. That one superpower is the key to our entire modern grid. But here's what might be the most amazing part of this whole thing. The grid isn't just a static system of wires. It has to perfectly match the amount of electricity being generated with the amount being used across the entire country every single second. If millions of people suddenly turn on their air conditioners, power plants hundreds of miles away have to ramp up production instantly to meet that demand. When you think about that, this constant real-time balancing act happening 24/7, you realize the grid is so much more than a machine. It's like a vast interconnected nervous system, constantly sensing and adapting to our needs. In a very real way, it's alive. So the next time you walk into a dark room and you flip that switch, just take a second. Remember the invisible highway, the genius voltage trick, and the massive living machine that completed an absolutely impossible journey. All for you in an instant.